video for lesson 2. So we're going to start with example 1, which says use the graph to evaluate the following. So it's really the same as function notation, except we just have 2 parts to the graph. F of -2. When I'm finding this, the -2 is an x value. So go to where x is -2 on the graph. Now this one has 2 outputs. So you need to decide which point do I use, the open dot or the closed dot. Well, the open dot is just placeholder, so I'm going to use the closed dot, which has an output of 5. For f of 3, that 3 is also an x value, so I'm going to go to where x is 3, go up onto the graph, and I get an output of 6. Finally, f of -8. Now that -8 is an x, and that -8 is actually not even on the grid here. However, since I have a constant function here, that means the value of 5 is not going to change, and that will be the y value for all the x's to the left of that closed dot. Right? Pretty simple. Number 2 is also very simple, except I have an equation that has a lot of parts to it. So, renumbered them. We'll start on the A that's up here on the right, h of 3. Now I need to decide which equation do I use for 3. So I figure out which inequality does 3 fall into. And 3 is in between 0 and 4, so I'm going to use the middle piece of this graph, the equation there. So I'll put 3 in for x, I'll have 3 squared minus 11. That gives me 9 minus 11, which is -2. Now let's jump down to the second A, B right here. H of 4, that 4 is an x. Now when I look at my domains, I have a 4 in 2 domains here. The 4 is actually only included in the bottom domain, right? It's not included in the middle one. It's less than 4. Here I want to be equal to 4. So I'm going to use that bottom equation. I'll have -x plus 5, which here is going to equal 1. And finally, the last part. I have h of -4. That -4 falls in this first domain. It's between -5 and 0. So I'm going to use this absolute value equation. I'll have the absolute value of 7 minus -4. That will give me the absolute value of 11, which is 11. All right, so not bad with the equation, not bad with the graph. Let's combine those together to do some composition of functions. All right, we've done composition of functions before. Let's just put it all together here. So I'm finding g of f of -3. That -3 is an x value. So I'm going to start with the function of x, which is the graph. I'm going to go to where -3 is, and I get an output of -2. I'm not using the open dot because I have a closed dot with a value at that place. So the output's -2 there. Now, what I do is I take that -2 and I put it into the function on the left, which is g. So I'm going to go over to g here and find which domain does -2 fall into. It looks like the top one because -2 is less than or equal to 0. So I'll put -2 in for x here. That gives me 4 plus 10, which is 14. That would be the answer. For B, I'm going to do g of 5 first. So I have g of 5 here. 5 is an x value, so I'm going to figure out which domain the 5 falls in. 5 is equal to 5 here. So I'm going to use the bottom equation. That output is just -7. It's constant. So I take that -7 and I'll put it in to the function of f. And -7 is over here. If I went down to the graph, I'd be on that constant function of -2. All right, next I have f of 0. So I'm going to start with f of 0 on the inside. And that's my graph. So I use the graph at 0 here. Again, there's a closed dot and an open dot. I use the closed dot. That takes over. Now I take that 0 and put it back into the function of f. Again, it's the same problem. So f of 0 equals 0. All right, and finally, D. G of f of 3. F of 3 here. I'm using my graph again to start. So I go to 3. I get an output of 3. Now I'm going to put that 3 into the function of g. So in the domain, the 3 falls into this middle domain here. It's between 0 and 4. So I'm going to put 3 in for x. I have 1/2 times 3 plus 4. That's 1.5 plus 4, which is 5.5. So hopefully evaluating with these piecewise isn't too bad, and throwing back in some composition of functions is also not bad. The second part of these notes is writing piecewise functions. All right, so we're going to be given a graph. You need to identify the equations in the domain for each part. So let's break it up for the first couple here. I'm going to start on the left, and that's the left portion here. So we're going to do everything for the left portion. That last portion of the graph, I need the equation. Now this is a line, so we write lines in slope-intercept form typically, y equals. And my slope here looks like it is going up to right 1, so 2. I put x, and if I followed this slope from the endpoint, I would cross the graph at 3. So that's my y-intercept. Now this is a ray, which means, and the ray is going to the left, so all those x's are less than, because it's an open dot, the x of -1. Now let's talk about the right portion. The right portion here is also a ray, and we're going to find the equation and the domain for that guy. So I start here with the slope. This slope looks like it's negative, and it's going down 1, right 1. So negative, y equals, negative x, or negative 1x. Excuse me, and the y-intercept is also at 3. Now this is also a ray again. You see the arrow on the end, and it's going to the right. So I want all those x's that are greater than or equal to -1. Now the way that I write this as a piecewise function is I take each of those equations in domain and put them within the bracket. The only thing is I do not write this y equals anymore. I'm just going to write the equation 2x plus 3. I don't need the y equals because that f of x is acting like the y equals. I put a comma, and then I write the domain that went with the equation. Same thing for the right portion. I had negative x plus 3 as the equation, and my domain greater than or equal to 1. All right, let's do the domain and range of this graph. The domain here, I start on the left. I have an arrow. My domain is coming. I get to -1. Then I continue up here. I have a value, so I continue to the right, and that arrow means I go forever. So my domain here is -infinity to infinity. I'll do the same thing for the range. I have an arrow going down, so I'm coming up forever. When this piece ends, I'm still connected over here. So I go up, but my graph stops at 4. So my range goes from -infinity up to 4, and the 4 has a closed dot, so I close the bracket. Example 2, 2 more here. All right, example 2 is also linear. So I have 3 parts to this graph. So let's talk about the left portion. All right, so I have, let's find the slope here. So the equation of this line is y equals, my slope is positive 2x. And if I continued this slope, it looks like I would cross at a y-intercept of 7. Now that piece is a segment. So I have 2 pieces to my domain. Looks like I start at -4 with a closed dot, put my x in the middle, and my domain ends at -2 with an open dot. The middle portion of this graph, different color here, is a constant function, right? Constant or horizontal lines are written as y equals, and that y equals 1. Now it's also a segment, and I have a closed dot on the left at -2, and on the right I have an open dot at 4. All right, finally, the right portion of the graph is a ray. Oops. All right, I have a ray here, and let's find the slope. It looks like it's a negative slope. It looks like down 1, right 2, so -1/2. And then the y-intercept, if I continued the other direction, looks like it would be at 5. That domain, the arrow is going to the right, so I want all those x's greater than or equal to, because it's a closed dot, 4. All right, now we're going to put all of those together in the function notation. So I don't use the y's again. Remember, I just do the 2x plus 7, and its domain. And then I pull that domain from that first portion, -4 to -2. And then the second function was y equals 1, so I just put 1, comma. My domain was from -2 to 4. And then that last graph had an equation of -1/2 x plus 5. And then my domain was greater than or equal to 4. All right, let's do the domain and range of the whole thing. All right, it looks like on the left, I actually start at -4. So I continue here. When I get to -2, I still have a value, so I go all the way to 4. 4, I still have a value on this graph, so I continue with the arrow that goes forever. So my domain here starts at -4, inclusive, but goes to all the way to the right to infinity. If I look at the range, the arrow here, it's tricky. This arrow is going down forever. So I'm actually coming from -infinity up, and the highest value on my graph is at 3. There's a closed dot there, so there is a value. So my range goes from -infinity up to 3 with a bracket. All right, now typically our problems are going to look more like example 3. I'm not going to give you all the left portion equation, right portion domain. I'm just going to say write the equation. So let's use this one here. Sorry about that, the announcements came on. Okay, let's finish up here. So I'm not going to give you all the blanks all the time. I'm just going to give you a graph, and this is what's accepted on the ACT, the SAT. Any other time you're going to write an equation, you should just be able to write it. So let's do the first equation here, the left portion. Okay, this is a segment, and it's a line. So my slope of the line is down 1, right 3, so -1/3 x. And if I continued that slope, it looks like I'd cross the axis at +4. That is a segment, so I have 2 endpoints here. My left endpoint's at -9, that is a closed dot. And then I have a closed dot again at -3, so that's that domain. The middle portion here is a constant function. That constant function's at -2. It's also a segment. That domain is from -3 with an open dot until 0 with a closed dot. Finally, you should be able to identify some parent functions here. That is a parent function. That's the square root of x. And the domain there is a ray, there's an arrow on the end, are all the x's that are greater than 0. So you should know some of your parent functions. They might show up now and again. Finally, the domain and range, let's see, of the whole graph. So I'm going to erase this highlight. We'll take a look. So my domain here, I have an endpoint at -9. I continue to -3. Now -3 does have a value, but the graph picks up down here, so my domain continues. There is a value at 0, so I can continue with the arrow here to infinity. So my domain goes from -9 inclusive to infinity. Now let's talk about my range. The range starts at -2. Then there are no y values here for a little while. So my range starts with just the number -2. That's it. That's the y value. I'm joining that together. I'm unioning it with the other part of the domain. Now this arrow, a range, this arrow goes up forever. So my graph starts again at 0, and it goes up forever, including that segment. So my range would pick up at 0 with an open dot and go to infinity. All right, there's some practice you can try on this. Check the key on Canvas if you need any help.